So here we have a function given by sine of x over pi minus x. So we need to determine the limiting value of this given function when x approaches pi. So when we do a direct substitution for the value of x here, we'll have sine of pi over pi minus pi. Now sine of pi, or sine of 180 degree, is 0, and we also have a 0 in the denominator. So this is an indeterminate form. So that means we'll need to simplify the given function. Now what we're going to do, we're going to change the limit from x to h. So we have limit h approaching 0, then x will get replaced by pi plus h divided by pi minus x gets replaced by pi plus h. Now we know that sine of pi plus theta is equals to sine theta, and the pi plus theta means we are in the third quadrant. And so in the third quadrant, the tangent function is positive, everything else is negative. So that means we'll get negative of sine theta. So that means our function will now become limit h approaches 0, negative of sine h divided by pi minus pi minus h. So the pi and pi gets cancelled. We'll have negative sine h over negative h. So the negative will get cancelled, leaving us with sine of h over h. Now this, as per our limiting definition, our definition of limit, the limiting value of sine h over h when h approaches 0 is simply equals to 1. So that means our given limit when x approaches pi, sine x over pi minus x, the limiting value is going to be equals to 1. Let us do another problem. So here we have the function sine of 2x divided by cosine of x. We need to determine its limiting value when x approaches pi over 2. So when we substitute for the value of x, we'll have sine of 2 times pi over 2 is going to be pi. So we have sine of pi. So sine of pi is equals to 0, and in the denominator we have cosine of pi over 2. So we have sine pi over cosine of pi over 2. Now sine of pi is 0, and so is the value of cosine pi over 2. So we have an indeterminate form. So that means we'll need to change our limit. So we have limit x. So we're going to change the limit from x to h. So we have h going to 0, sine of 2 times. So x will get replaced by pi over 2 plus h divided by cosine of pi over 2 plus h. So we have in the numerator limit h approaching 0, sine of 2 times pi over 2 will be pi. So we have pi plus 2h divided by cosine of pi over 2 plus h. Now we know that sine pi plus theta is equals to negative sine theta, and cosine of pi over 2 plus theta is going to be equals to sine theta. Now pi over 2 plus theta means it's in the second quadrant. So in the second quadrant the sine function is positive, everything else is negative, and since we are working with a cosine function here, so the result will be negative. So we have negative sine theta. So that gives us limit h approaching 0. So we have negative sine of 2h divided by negative sine of h. So the negative and negative goes away, it gets cancelled, and also we can expand sine of 2 theta 2 of h as 2 times sine of h times cosine of h divided by sine of h, so the sine of h and sine of h gets cancelled, so leaving us with 2 times cosine of h. So we substitute the value of h, so we have 2 times the cosine of 0, so that gives us 2. So this is going to be the limiting value of a given function when x approaches pi over 2. Let us do another problem. So in this particular question, we have the function cosine squared x divided by 1 minus sine of x. So we have to determine the limiting value when x approaches pi over 2. Clearly, we have a 0 over 0, which is an indeterminate form. So we need to simplify our given trigonometric function. Now, in this particular question, instead of changing the limit from x to h, so we're going to apply the identity that cos squared theta plus sine squared theta is equals to 1. So we can write cos squared theta as 1 minus sine squared theta. So our function now becomes limit x tends to pi over 2. So we have cos square x, so that will become 1 minus sine squared theta over 1 minus sine theta. Now in the numerator we have 1 minus sine squared theta, so the 1 can be also rewritten as 1 squared, so that we have limit x tends to pi over 2. Now the reason why I wrote 1 as 1 squared is because now it corresponds to the identity a squared minus b squared, which is simply equals to the product of a minus b and a plus b. So that gives us 1 minus sine theta. So that is sine x. I made a mistake here. Let me change it. So here will be x. So this is sine squared x and this is sine x. So we have 1 minus sine of x multiplied by 1 plus sine of x, all divided by 1 minus sine x. Now we have 1 minus sine x, which is the common factor in both the numerator and the denominator, so we can cancel it out, and that leaves us with limit x tends to pi over 2 1 plus sine of x. Now we substitute for the value of x, so we have 1 plus sine of pi by 2. Now sine pi by 2 is equals to 1, so we have 1 plus 1, so that gives us a limiting value of 2. Let us do another problem. This problem is quite similar to the previous one, only then we have the function in the reciprocal order, in meaning the numerator, which was cos squared x in the previous question, is now in the denominator. Similarly, 1 minus sine x was in the denominator, now it's in the numerator. So going in the similar fashion, so we have limit x tending to pi over 2. So we have 1 minus sine of x, because cos squared x will be equivalent to 1 minus sine squared x, which will be equals to limit x approaching pi over 2. We have 1 minus sine x divided by 1 minus sine x times 1 plus sine of x. So that will leave us with 1 plus sine of x in the denominator, 1 over 1 plus sine of x. Now substituting the value of x, we get 1 over 1 plus 1, which is 2. So this is going to be the limiting value of the given function when x approaches pi over 2. Let us do another problem. So we have the function given by cos of x minus cos of a divided by x minus a. We have limit x going to a. Now when we substitute for the value of x, we have cosine of a minus cosine of a, which is going to give us 0 in the numerator, and we have a minus a in the denominator, so that's also going to give us a 0. So that means we have a 0 over 0 indeterminate form. So we are going to change the limit. So we have limit h tending to 0, so that cosine of x now will become, that gets replaced by a plus h minus cosine of a divided by, so we have x that gets replaced by a plus h minus a. Now we're going to use the identity, cosine of a minus cosine of b is simply equals to negative 2 times sine a plus b over 2 times sine a minus b over 2. So let us apply this, and this is going to give us limit h approaching 0. So we have negative 2 times sine a plus h plus a, so that means we have 2a over 2 times sine of, so we have a plus h minus a, so the a and a get cancelled, so we have h over 2 divided by, so the a and a gets cancelled in the denominator, leaving us with h. Now what we're going to do, we're going to divide the denominator, which is h, by 2. So that would mean we have to take care of that extra 2. So we multiply the entire function by half. So doing that, we can get rid of the 2 from the numerator and the denominator. And we have negative limit h tending to 0. So we have sine 2a plus h whole divided by 2 times the other function, which is, we'll be using the limiting value. So we have limit h going to 0, sine h over 2 divided by h over 2. So this by definition is going to be equals to 1. So that will give us, that will leave us only with the single function sine 2a plus h over 2. So substitute for the value of h. So that is going to give us negative sine. So we have 2a plus 0 over 2. So that gives us the final value of negative sine a. So this is the limiting value of the given function when x approaches a.